friends! Welcome to Coding Garden with CJ. Welcome to Code Katas, episode number 24. If you're new to the show, you can see all of the solutions from past episodes on GitHub. It's at github.com/codinggarden/code-katas. In the last episode, I didn't solve any katas, but we kind of organized the repo so you can see episode number, go into an episode. Well, that's not a good one. That has all like the generation code. But if you go into a specific folder, you can see all of the solutions for that specific episode. If you look at the README, it has a breakdown of every episode and every kata that I solved. And I'm going to solve some more tonight. Before we get started, let's say hello to all the wonderful people in the chat. Hello, One More Coding. Welcome to the stream. Hello, Everfavio. Hello, Rabbitworks. Hello, Bob's Paradox. Hello, Josh. Welcome. Hello, Kaizen Media. Hello, Amadou. Hello, Ran. Hello, Danielle. Hello, Oliver Wright, who's typing with their caps lock key on. Hello, Danielle. Or did I say hello, Danielle? I did, but hello. Hello, Edgar. Good morning to you. It's an evening for me, but good morning. Hello, Vias. Hello, Handika, who asks, when does this start? Right now. You're watching it. It's live. It just started. Hello, Coddleswoo. Hello, Heisenbrock. Hello, Kakashi. Hello, Charlita. It says, hi, CJ, finally caught alive. It's awesome. Welcome. Hello, Justin Ox. Welcome back. Yeah, and Danielle got double hellos, and now you've gotten a triple hello, Danielle. Cool. So for this episode, I actually have not chosen any katas yet, so I'm going to choose them live and solve them live. If you have any suggestions, feel free to throw them in the chat. But I'm going to start on an easier one. So on Code Wars, they get easier as the number goes down. So 8Q is the easiest, and then 1Q would be the hardest. I'm going to start with 7Q, get a little warmed up, and yeah, we'll go from there. So I'm going to sort by katas I have not trained on. Hello, Anaboth. Welcome to the stream. And JT, welcome. I'm getting really lucky with pronunciation. Like all the people that pop up in the chat, I seem to say their name decently. And hello, this is going to be a hard one. MD Mahboober Rahman from Bangladesh. Welcome to the stream. Cool. But yes, no katas picked out. We're going to pick one. I guess we could choose a specific tag. Actually, I can do mathy type ones, but I don't always like to do them. Let's see. Let's do arrays. Let's start with arrays. This first one, the highest profit wins. Let's see what it's about. Ben has a very simple idea to make some profit. He buys something and sells it again. Of course, this wouldn't give him any profit at all if he was simply to buy and sell it at the same price. Instead, he's going to buy it for the lowest possible price and sell it at the highest. Write a function that returns both the minimum and maximum number of the given list array. I see. So it's pretty easy. Basically, yeah, you're literally just finding the minimum number in the array and the maximum number in the array. Why not? Let's start here. Okay, so I am going to do this locally. So here I'm going to create a new file. We're going to call it that.js. We're going to start training on it. We'll copy our function. And do we have some basic tests? We'll just do like these two basic tests. So basically, given an array, you must return an array that has the smallest and largest number that was in that given array. Okay, I'm going to start up Quokka, which is a tool plugin that I have for VS Code that actually runs the code inside of my editor. You can see it's complaining about tests. Let's just make these a console log. And it will log the output here. So right now, that's not right. Oh, we need to actually call the function. So if min-max is called with this array, we should get back 1 and 5. Right now, it's just returning 0, 0. And if min-max is called with this array, we get back 0, 0, but it should be getting back that array. Okay, so how are we going to do this? Let's write out some pseudocode. Now, one thing which would probably be the easiest, before I talk about it, let's take a quick stretch. There's a question in the chat from Blaums. Do you have plans to follow up the pizza API stuff with a CLI or front end? I have thought about creating like a pizza builder that creates the JSON object for the pizza that you want to order. Like you would choose your crust, choose your cheese, choose your toppings on the left or the right of the pizza, and that would give you like an options object that you could send, well, that you could then send to the API. So I have thought about doing that. And it would be cool if there was just a straight up CLI where you could just, like type a CLI command that orders the pizza. I've thought about it. And Kakashi is from Brazil. Hello. Hello, Clark. Welcome to the stream. And hello, Kamalesh from India. That's awesome. Okay, so probably maybe the easiest way to do this is to first sort the array and then return the first and last values from the array. Right? That should do it. If it sorts it from lowest to highest and you just return the first one and the last one, you have the min and the max. I think I'll do this first just to show how it's done, but I think the issue with that is sorting algorithms can have a higher complexity, so we could potentially solve this in one iteration, but let's do it the easy way first. Okay, so to sort the array, we could use the built-in sort. Do array.sort, and I believe sort is an in-place sort, meaning it modifies the array that got passed in. So we shouldn't need to assign it to a variable, it should just sort it in place. And then we need to return an array with both the first and the last value in it. So we could create some variables for it. We could say first value, probably like, let's call it min, is going to be array at 0, because the first thing in the array should be the minimum thing. And then the max should be array at array.length -1, so the thing at the very end of the array. And then we need to return an array that has both min and max inside of it. Ta-da! We've done it. Wait. I think this broke. With a very large number? Let's do this. If we log the array beforehand, let's just run this one. So we log the array before, and then we log the array after. It's already in sorted order, but let's try swapping it. Let's say we put like 5 at the beginning and 1 at the end. Yeah, it should still work. So when the array gets passed in, it's not sorted. Then we sort it, and then we return the first and the last one. So that looks good. But what's happening here with this very large number? This is basically saying that this number is larger than that number? Anyone know what's happening? This would be a good case for actually solving it as we go. This is very weird. Let's just do this. Is 2, 3, 3, 4, 4, 5, 4 greater than 5? Yes. So it should be at the end of the array. Am I doing anything weird here? Is it string comparing? Oh, yes it is. Good call. Thank you, Alka. Okay, let's look at the documentation for sort, array sort. But yes, Alka is absolutely right. By default, array sort doesn't sort numbers. Good call. So by default, it just uses like the Unicode values of the thing that you passed it in. So it's actually using a string sort. If you want to sort numbers, you have to give it a comparison function like this. So we definitely need to do that. Okay. Yeah, and it worked for the first one because that one was just in order to begin with. But then we have this one. So we actually need to pass in a comparison function. So the comparison function takes in 2 numbers and then compares them. If you look at the docs for the compare, basically you can follow this pseudocode. So you can say something like, if A is less than B, then you return -1, which means that A comes before B in the sort order. If A is greater than B, then we return 1, which means A comes after B in the sort order. And if it's neither of those, then that means they're equal, and we return 0 because they're in the same place in the array. Cool. And that works. Thanks for the tip, Alka. Okay, so that's great. Let me show a trick for this comparison function. So because we know that when you do subtraction on numbers, you're either going to get a negative value, a positive value, or 0 if it's the same number, this function can just be simplified to A minus B. And it should work in exactly the same way, which is cool, right? And then because we're using arrow functions, we can get rid of the return and just write it as a one line. Sweet. So that's easy enough. Let's look at the chat. Yeah, that was it. People were calling out. Nikhil was saying you got to use the compare function. Yeah, and Nikhil was saying, isn't the default sort lexicographical? Yes, and that it basically turns them into strings and then compares their Unicode values. Okay, we did it. Yes, and Alka's mentioning it just needs to be -0 or positive. So we could do this -1, 1, 0 thing, or we just return the subtraction, which gives you a -0 or a positive value. Fantastic. Hello, Desi. Welcome to the stream. Okay, here's the thing, though. I want to do this in a single iteration because sort, depending on how they implement it, has to actually compare every value to every other value. So like it potentially could be n times n comparisons. I think we can do this in a single pass of the array. So let's try to do that. Okay, so what I'm thinking is we have two variables, min and max. So we have, let's say, min variable set to the either the first of two values in the array. So what we're going to do is we're going to take the first two values in the array, and we're going to start from the left and go to the right. Of those two values, whichever one is smaller goes to min, and whichever one is larger goes to max. Then we start iterating from the third place, and we compare every value with our min and max and decide if we need to replace it. So if it's less than the min, then we change it to min, and then take the current min and make it the max. If it's greater than max, then we change it to max, and then keep on iterating. Let's write that out as pseudocode, though. So min variable set to the lowest of the first two values in the array. Then we need the max variable set to the highest of the first two values in the array. Okay, so at this point, if we're just looking at the first two in the array, we have the min and the max. And then we need to iterate up from the third value till the end. So iterate up from the third third value to the end of the array. And then we do our comparison. So if the current value is less than the, well, I might have misspoke earlier. So let's say if the current value is less than the current min, set the value to be the current min. Easy. Okay. I think at some point we would need to swap the two values. Maybe not. If the current, let's say else, if the current value is greater than the current max, set the min to be the current value. And in this case, we're going to set the max to be the current value. I think this should work. When I stated it earlier, I was thinking we would have to maybe like swap up. Like if we find a min that is less than the current min, would the current min become the max? No, because the max was already greater. This should do it. This should do it. Oliver's saying, quick, use a reduce. After we solve it this way, we can turn it into a reduce. Ooh, that's a Alka is saying explicitly use math.min or math.max. Yeah. I was thinking, could we do like some sort of spread to find the minimum value and then some sort of spread to find the maximum value? That's another idea. Let's do that afterwards. Okay. And then at this point, return max and min. All right, let's do it. So we need to compare the first two values in the array. So let's say something like if array at 0 is less than array at 1. And initially, we just need two variables. So we need min and max that don't have any values because we're going to set them. And we're using let because we're going to be reassigning them. And so if array at 0 is less than array at 1, then we'll say min equals array at 0 and max equals array at 1. Else, we'll just do the opposite. And if they're equal to each other, then this will still work because the min and the max are both set to the same thing. Cool. So then we'll just swap them. We'll say max is array at 0 and min is array at 1. Okay, so we've done that there. And if our array was only length 2, we'd be done right now. But if it's not, we're going to iterate up from there. So we need a for loop that goes from the second index, because we want to start right after the first index. And then we're going to go to the end of the array. And then we have the current value, which is going to be the array at the given index. And then we have our logic here. OK. If the current value is less than the current min, set min to be the current value. So if current value is less than min, we just say min equals current value. Else, if current value is greater than max, set max to be the current value. So we'll say max equals current value. Okay? And then after this one iteration, we should have the min and the max. So we then want to return min and max in the array. And that seems to work. Cool. I wonder if we can get some more complex things to throw at it. Oh, here's one thing we're not taking into account. What if the length of the array is only 1? Let's see what happens with our function. Yeah, so we need to take into account if the length of the array is 1, then we need to just return that value. Let's do that right here. If array.length is equal to 1, return an array with array at 0 in there twice. Cool. And we need to do that for every time we do this. Oh, I guess this would technically work. Array length is 1. So these two would still work because we would just be sorting an array of length 1, and then we would be returning min and max still. Okay. So that's great. We're there. Oliver Wright is saying this will fail on 100, 1. Are you talking about Alka's solution? I don't know. We'll see. So this is cool, and let's talk about performance though, because it's kind of hidden here because we're just using a built-in sort function. But sorting can be expensive because you potentially have to compare every value to every other value, whereas in this case we're just doing one pass of the array, and in the one pass of the array we find both the min and the max. Oliver's saying if I have 101, it's gonna fail? I don't think so. Yeah, it works. It works. Mainly, it's because of this first if statement I have here. So if the length of the array is just 2, it's basically done in the very first step, and then it doesn't have to go through the the loop here. Oliver's saying don't use an else if though. So what implication does it have if I just have if? Hello, Billy. Welcome to the stream. Yeah, so let's take a quick stretch. But the reason this works is before I do any sort of iteration, I first look at the first two values in the array. Kaizen is asking my syntax highlighter. I'm using SETI Monokai for Visual Studio Code. This is the one. It's pretty. It's very rainbowy. Here, I'll share it. There you go. So that was great. Now I want to try doing using like math.min and math.max. Yeah, let's see it. Cool. So here's what I'm thinking. We can use the built-in math.min function to find the minimum value in the array. And then we can use the built-in max function to find the max value in the array. And then we have our min and our max. So min max takes in the array. We have min, and this is going to be math.min. And so math.min takes in any number of arguments. So you could do 1, 2, 3, 4, 5, 6. You could do it like that. But in our case, our values are inside of an array. So this is where we can use the spread operator. So we can say spread the values of this array as arguments to the function, and that should find the minimum. And then we can do the exact same thing with max. Like that. And then we'll just return an array with min, comma, max. And it works. Cool. Yeah, it works. This is ES 2015 syntax. The way you would have done this in the past is you could apply, or you could use call. So if you say call, you can give it a this value. So what should, and then you can give it an argument array. So in this case, we don't need I don't think we need a this value, but the argument array is just going to be r. So that'll do that. And then similarly, we can do this. So we can say there is no this value, but the arguments I want to pass in are the r. That doesn't seem to work. Do I need to pass in math as the this value? How does call work? Let's see how call works. Call. Am I missing an argument? So this, and then you need the argument array, which can be anything. I want apply. Do I want apply? Because I am invoking the function. You're right. I think you're right. Null and then the array. That works. Okay, so I do want to apply. I see. And if I wanted to use call, then I would have to spread, which at this point wouldn't make as much sense. But I like using the spread operator, so that's cool. Cool. Can anyone think of any other way to solve this problem? So we have sorted it, found the min and the max. We have iterated it once to find the min and the max. In this case, we had to iterate twice, but it's not a nested iteration. So technically, this function has the same complexity as this one that we wrote, because it's just one iteration to find the min, and then one iteration to find the max. Yeah. Oliver's saying, now implement sleep sort for constant time performance. I'm not familiar with sleep sort. Let's look it up. Sleep sort. In general, sleep sort works by starting a separate task for each item to be sorted, where each task sleeps for an interval corresponding to the item's sort key, then emits the item. Items are then collected sequentially in time. Whoa! That's it's a constant time performance, but if you have really large numbers, it could take a very long time, right? Because is this saying you have the numbers in your array, and then for each one you sleep, like if the number is 5, you sleep for 5 seconds or 5 milliseconds, and then insert the value. So each thing is sleeping for a longer time, so it gets inserted at the correct place. Is that what this is saying? That's very interesting. It's bad, but it's constant. Cool. Okay, I'm gonna move on. This was fairly easy, but pretty fun. I like, which one do I like? I like this one. I'm gonna submit this one to Code Wars. Sample tests. Those passed. We're gonna do an attempt. And Oliver has shared their solution. Oh, is sleep sort? This is sleep sort. That's fantastic. Here, I'll show it. We did it. Submit final. Cool. Yep. So this person did the same thing. Math min, math max. Same thing with they used apply instead of spread. This person did the sort. Min and max, min and max. Oh, I forgot to do a reduce. I want to try a reduce. This person did a hard to read reduce. I think I'm going to try to do a reduce. But this is Oliver's sleep sort. Does it visualize anything? Just the result. So we have our delay function, which just sleeps for that amount of time. Yeah, and this is the one that is going to take a long time to sort because it literally has to sleep for, where's our thousandths place? 233 seconds, and then the sort will be done. But it's constant time because you can always guarantee that it's going to take that long to sort. Cool. Yeah. Note that it takes around 4 minutes to sort this one. That's cool. Okay, yeah, I do want to try this with a reduce. That'll be fun and interesting. And just a plain old good time. So here we go. I'm gonna use this one as a basis for the reduce because this is iterating the array, and I think we can do it in a similar way. Yeah. Okay, where do we start? I'm thinking, like, do we find the min and the max first, and then do we reduce from the second index up, or can we reduce all in one go? I think we can reduce all in one go. Okay, so I'll put my code right here-ish, but we want to return array.reduce. We're going to be reducing to an object that has min and max on it. Or I guess technically we could be reducing to an array of length 2. Okay, so let's call this min max, and then you have each value. The reducer is going to start off with just an empty array. And I guess what I'm thinking is if array at 0, we're going to start off with null in both places, and we'll just have some conditional up here. If that value is null, set it to the current value, because is that gonna work? I don't know. We'll figure it out. But basically, this logic can go inside of our reduce. I know that for sure. So we're going to be doing the comparison here, but instead of current value, we just call this value. And we can destructure this to grab off the min and the max. Well, we'll use array destructuring, min max. And then we'll return an array with min max. But we need to handle the case where the values start off as null. Okay, so can we do something like if min is not a thing, then min equals the value. And then we'll do another else if max is not a thing. We'll set it to the max. No, but then we could end up with the scenario. Okay. Because that could end up where max gets set to the first one and not the second one. How can we do this? Scared of all this. Yeah, I'm getting a suggestion to just use infinity and negative infinity. That'll work. Why not? Wait. That's how that works, isn't it? So, min, max. Oh, it needs to be the opposite. Does it need to be the opposite? Because it's never going to be less than negative infinity. Let's start it off with array at 0 and infinity. No? Do I have to flip it? So I want the max to be infinity. And the min to be infinity and the max to be negative infinity? Yeah, that's not going to work because it'll never be greater than it. Well, that's because I have this else if, right? If I get rid of the else if, I think it'll work. Yeah. And the reason the else if blocked it is because it would have never been less than the min. But that works. Cool. Let's see how they did it on Code Wars because they did use a reduce. They just started off with the first two values in the array. Then if the min is less than the current value, just return the min. Else it return the value. Oh, we're returning an entire array. Okay, so if the min value is less than the current value, keep the min value, otherwise set it to the current value. And then if the max value is greater than the current value, keep the current max value, otherwise set the current value to be the max. Interesting. Yes, and Rogue Soul is asking, is this my first kata? It is! I spent an abnormally long amount of time on this one. But yeah, this is my first one. We're going to keep moving. Let's pick another one. So, I didn't have to actually have any katas picked out tonight, so we're picking them as we go. Let's see. Yeah, just talking about that... it's called Sleep Sort. That's super interesting. All right, what topic should we choose? There's design patterns. That sounds interesting. What if we do strings? I guess puzzles would be cool too. Let's see what we got here with strings. Find the unique number. There's an array with some numbers. All numbers are equal except for one. Try to find it. This is interesting. I think, again, we could just use like a sort. Compare the first two and the last two. Might be too similar. I don't know if I want to do this one. Sort the odd. You have an array of numbers. Your task is to sort ascending odd numbers, but even numbers must be in their places. What? 0 isn't an odd number, and you don't need to move it. If you have an empty array, you need to return it. Okay, so odd numbers need to be sorted. So like, oh, I see. It's like you're sorting subsets of the, I think. No, you're sorting, but even numbers remain where they are. The odd numbers just get put in their place. So 5, 3, and 1 are all odd numbers that need to be sorted. 1 would go to the beginning, then 3 Then you have even numbers, then you would insert the odd number. This is also, I don't want to do sorting. We didn't sort ourselves, but I don't know if I want to do that. Let's take a quick break. Yeah, did I click arrays instead of strings? No? Oh, they're both selected, that's why. Let's get rid of arrays, because those are array problems. I want to do string problems. Okay, just strings. There's split strings. Complete the solution so that it splits the string into pairs of 2 characters. If the string contains an odd number of characters, then it should replace the missing second character of the final pair with an underscore. That's interesting. Yeah. Because we could iterate to do it. We could also do like a regular expression to find like 2 letters next to each other, each occurrence of 2 letters next to each other. Interesting. I'll hold on to that one. Weird string case. JT says, how long will it take him to realize he didn't click on strings? I sort of thought maybe that was the case, because those were all array problems. I don't know. Write a function to weird case that accepts a string and returns the same string with all even index characters in each word uppercased and all odd index characters in each word lowercased. The indexing just explained is 0 based, so the 0th index is even, therefore that character should be uppercased. That seems fun. I'll hold on to that one too. Let's look at like one more. IP validation? Write an algorithm that will identify valid IPv4 addresses in .decimal format. IP should be considered valid if they consist of 4 octets with values between 0 and 255. The input function is guaranteed to be a string. So basically, you just need to make sure that you have 4 numbers separated by periods. And they must be values between 0 and 255 without any like leading zeros or anything like that. That's also interesting. Should we vote on it? Like, this sounds fun. Weird string also sounds fun. Split string's not as much fun. Okay, between these two, let's do IP validation. This sounds interesting. Here we go. Yeah, and this one has lots of test cases, so that's cool. Okay, start up Quokka. Yeah, right now our function returns false no matter what. But let's just comment these out and just try in the most basic case. Okay. So here is my thought. We could split the string on period. Make sure that the length is 4. If it's not, automatically return false. And then if it is, make sure that each value is between 0 and 255 without a leading 0. Let's do that. Okay. Split string on period. If length is less than, if the length is not 4, return false. Else, iterate over sections. Are these called octets? Yeah, iterate over octets. If current value is not between 0 and 255, immediately return false. And then after all of it, we return true. Because if we make it out of the for loop and everything matched that, we'll ultimately return true. Okay, I think we'll do that. So First, we need to split it on the period. So we'll say octets is going to be string.split on a period. And so that will be all of our octets. And then we need to make sure that the length of this array is 4. So if octets.length does not equal 4, then we will just return false. Cool. And then otherwise, we need to iterate over the octets. So we'll just have like a basic for loop. Let's just call this value. Could call it octet. That could get confusing, though. Okay. If the current value is not between 0 and 255. Now, this gets tricky because we don't want numbers that begin with zeros. So we couldn't just do a direct comparison. We also don't want like characters. So we could do a regular expression because it is strings. Okay, well, let's just write it out. So if value dot mat, I mean, we could use a regular expression to first make sure that it is at least a number. So we'll say find a digit, one or more digits. If it doesn't have one or more digits in it only, so it must start and end with that. Start with a digit and end with a digit. Return false. So, like, if we were to test it on this, it should return false because the moment we see that these things are not all digits, it returns false. Let's see something like this. Yeah, so this has numbers and digits, but this regular expression only matches digits. It must start with a digit and end with a digit. Cool. So that handles those cases. But then we care about this case, where it starts with a 0. How can we say that the first value is not a 0, but it can't be a 0 if there's more than one value in it? Because if it's just length 1, then it can be a 0. Like this should technically return. Oh no, that's too high. But if you had like .0 right there, it should still return true. Cool. I'm going to catch up on the chat. Hello, Ricky Yu. Hi from Hong Kong. First time here. That's awesome. Welcome to the stream. Oliver says, just pass it to the built-in networking stack and see if it errors. That would be fun. I don't know if you can do that on Code Wars, though. Billy says, I love your streams. Thank you so much. Yeah, and Coddlesu is saying, I think you need to check if it has a leading or 0 or not. That's where I'm at right now, because this should not return true. This needs to return false. But if it's a single 0, then you still just return true. Alka's saying the maximum length would be 7. Or the minimum length would be 7, the max is 15. Of the whole thing, yeah? Oliver has a regular expression, so the values 1 through 9, followed by a digit of length 0 or 1. That could work. Right? I don't know. I'm going to do just like some manual validation. Let's just do it. So else if value.length is greater than 1 and value at 0 is a 0, return false. Easy enough. Else if value is less than 0 or value is greater than 255, return false. I think that should do it, because this checks for our special case where we have a leading 0, so it's working right there. That's great. But if we have a number that is just 0, that works just fine. And if we have a number like 10, that works just fine. And then we get into if the value is less than or greater than. Technically, we're using like the built-in coercion of strings, because when you use this comparison operator, I believe it's going to convert this into a number to compare it. Will it? I don't know. Let's see. Like, this should be false. Yeah, because 456 is greater than 255. Let's see how that works out. Like, if I do string 456 greater than 255, it actually returns true. So JavaScript under the hood is actually turning this into a number, because there's a number on the right-hand side. Okay. So I think we're there. If it's empty string, it's false. If it's not enough, it's false. If it's bigger than 256. If it has more than 4. If it has commas. If it begins with a space, our regular expression catches that. I think we did it. Yeah, I think we did it. Woo! Okay. Clark is saying, if 0 and length is greater than 1, return false. Oh yeah, JT is saying if I move this last else if. So if I move this last else if before, I think that makes sense, because then we would only check the weird case if it passed through that. So make sure the value is good. And then if you have a scenario like this where it's 0, 1, then we check to see that there's not a 0 at the first place. And this is the more likely case, so you have that condition there. I like that. Yeah, some people in the chat are mentioning, like, should we be checking for the minimum and maximum number of characters? We could. Like, even before this split string, we could say, like, if it's less than the minimum or greater than the maximum, there's no way that it's valid. Okay, how else can we do this? I think we could do it with a reduce. Let's do it with a reduce. I think. No, before we use a reduce, I think we can use like a higher order function right here. So this for loop could be turned into an every. So we want to make sure that every octet returns true here. So let's do this. Same code, but this we could just return octets.every. We're gonna get the value, and then all of this code goes in here. That. And so what this does is this will return true if every single octet returned true, but if any one of them returns false, it will return false. So this octets.every does a very similar thing as what this for loop is doing, because it can like short circuit, because the moment something returns false, it's just going to immediately return false. So this looks good. Yeah, I don't know if I want to do anything more than that. Yeah, we're still talking about what's the minimum and maximum. Okay. Can anyone think of other ways to solve this? I guess we could come up with like a really complex regular expression that probably satisfies this scenario and this one. I think that is something that Oliver came up with. Let's see. Actually, I want to test this regular expression. Let's take a quick stretch. Good point. Alga is saying we don't need an else here. We don't. We could literally just return true, because if it makes it there, then we want to return true. You are right. Cool. But let's go to like regex buddy or regex pal. Okay. This is our, not that. This is our regular expression. Does it match 1, 2, 3? Yes, it does. Does it match 100? No? I don't know. Maybe Oliver, update me on that regular expression. Because basically, I think what you were trying to do is write a regular expression that solves both this and this at the same time. JT is saying use sum and get rid of the returns. I guess how would that work? So, oh. Yeah, I like that. I think I could see how that works. Because instead of like the if else's, then it could literally just return that. Yeah. Yeah. I like that. Okay. So sum returns true if something returns true. So I think we're going to not it. So we'll say if none of these satisfy this, and then we can just return that or that or that. Does it work? It seems to work. So basically what this does is if any one of the octets returns true, then we know that it doesn't satisfy it. And if any one of them return true, then we flip it so that it becomes false. But if none of them match this, the sum is going to return a false, so we return true. Wow. Alka is suggesting maybe what Oliver meant. But yeah, Oliver, if you post it in the Discord, I'll take a look there. Technically, that still matches. Or does it? Full match. I don't know. Yeah, Oliver, send me something in the Discord and definitely check it out. Wowie. So this is just one giant regex? Okay. All right. So we're going to match 1 through 9. Oh, wait. Some digit or 1 through 9 followed by a digit, or 1 followed by 2 digits, or 2 followed by a digit 0 through 4. Wow. So basically this is matching any value from 1 up to 255, but not any value that starts with a 0. That's great. And then we just repeat that for every octet. Cool. The G flag was enabled? Oh, they took it off. Okay. Yeah, that's one way to do it. I was thinking of like can we take this and this to just be a single one? We probably can. I don't know if I want to take the time to do it. Let's probably move on to another problem. I do like this using the sum thing, but that is a really long expression there. Kind of like how verbose this one is, because it's sort of easy to understand. I'm going to submit this one to Code Wars. Sample tests. Those worked. We'll do an attempt. It works. Final submission. Yay. Oh, Oliver, I think they did exactly what you did. But they just said there should be 4 of them instead of having it repeated. So that's cool. Because it's that followed by a period. This is tricky because it's like eager, but then it ends with that. And there's 4 of them. I don't know. Weird. And then this one, I guess that's another way to do it. After you split it, you filter it to make sure that the length is still 4 after they've been filtered through your like comparison function. However, oh, and then to catch the number starting with a 0, they say, okay, does the number equal itself when you've turned it into a number, which would drop any leading 0. Technically, they don't have to do this toString thing. Or I guess they do, if they want to compare 2 strings without coercing the other string to a number. Interesting. Oh, wow. Oliver, look what they did. They required net and just used net.isIp. I didn't know you had access to node modules in here. They literally did what Oliver mentioned that people should do earlier. Just use like the network stack. Wow. Are there any comments on this? Yeah, let's look at the comments. I absolutely agree that this should be the best answer. I was working on this for a while and then realized this is for node.js, so my answer was the same. Is it because net is a core module? I've never used that before. Yeah, it's a core module. So you, like, in a node environment, you could require it in. Beautiful. Beautiful. Unbelievable. ROFL. Yeah, so yeah, you can use built-in node stuff. That's great. Cool. And then this is very similar to what Oliver did. Cool. That was a fun one. How are we doing on time? All right, let's pick like 1 or 2 more, and then I'm going to go. Cool. All right, we're going to go down to 5Q. And for this one, let's solve a puzzle maybe. Puzzles. That's a good point. Oliver's saying you would still want to do .is IPv4 because technically they're allowing IPv6, which is it's like a MAC address. It has colons in it instead of dots. Yeah. Yeah, and JT is asking, how does that only have 34 best practice votes? Because that's the thing. Like, a best practice would just to use the thing that's like battle tested and like built in rather than writing it yourself. Well, at the same time, Code Wars is to practice like solving these kinds of problems. You shouldn't use something like that in production code. Let's see. Okay, is my friend cheating? A friend of mine takes a sequence of numbers from 1 to n, where n is greater than 0. Within that sequence, he chooses 2 numbers, a and b. He says that the product of a and b should be equal to the sum of all numbers in the sequence, excluding a and b. Given a number n, could you tell me the numbers he excluded from the sequence? No. I mean, I could, but I don't want to right now. Escape the mines. poor miner is trapped in a mine and you have to help him to get out. Only the mine is all dark, so you have to tell him where to go. In this kata, you'll have to implement a solve method. It has to return the path the miner must take to reach the exit as an array of moves. And there are 4 possible moves. So map is a 2-dimensional array of Boolean values representing squares. False for walls and true for open squares where the miner can walk. This seems interesting. I don't know if I want to do it though, but basically like you're given an array that represents a map that the miner can like walk through, and you have to solve a path through the map. This is like a pathfinding algorithm basically. I don't want to do a pathfinding algorithm right now. Simple time bomb. A bomb has been set to go off. You have to find the wire and cut it in order to stop the timer. There's a global property that holds the key to which wire to cut. Find that, and then you can cut the... What? Cut the wire with the wire key. What? Okay, this just seems super interesting. For one, I think I would have to solve it inside of Code Wars because I could, like, find the property in... the global object that doesn't belong there. So this is more about like let's try it. Let's just try it. I wonder if we have like a set time. Okay. Yeah, find the wire and then cut the wire. So here's my thought. Something like node.js list of built-in globals. List of global variables in node.js. Okay, the built-in properties of the global object are non-enumerable, so object.keys doesn't return them. So I should be able to just do object.keys, and that should give me the one that doesn't belong. Like if I go into a node environment and then say like object.keys of this. If I do object.keys of global. I guess because I have these, I guess I want to make sure I'm in the same node environment because they're in 8.13. Let's install 8.13. Okay, so I installed the same version of Node that Code Wars has. Now, if I go into Node and do object.keys of the global, what do we get? Seems like a slightly bigger list. But here's what I think we can do. So we take this list of known things and we find the one that is not that one. So let's do, okay, so this is the list of all the known things. And we then want to take the current keys. So like, let's just call this keys, and that's going to be object.keys of, actually I have a better idea. Let's turn this into an object. Yeah. I guess I could just do is like includes. Okay, so we create our keys. That's going to be object.keys of this. And then I need to iterate over keys. And for each one, check and see if it's in this array. So let's call this current keys. Then we have our valid keys. And then we'll see... Whoa, did not mean to do that. As we iterate over the current keys, if we find something that's not in valid keys, we have found our key. So we'll do, so wire is there. We'll just say current key, valid. We'll do current keys. We're going to iterate over current keys. Oliver's saying you should use diff on the command line. Well, I want to solve it all in one go. Like, I don't want to, like, console log here and then go back. Like, I want to submit this and it just solves it. Okay, so we'll do valid keys. Let's just iterate over current keys. Okay. So we're going to iterate over the keys. And then we're just going to check and see if valid keys has that. So if valid keys dot includes, I think we can use. So we'll say if valid keys does not include that, then we found our key. So we'll say wire equals current keys at I. I think includes is in node version 8. Array includes. Yeah, whether it includes a certain value. Okay, so if valid keys does not include the current key, we found the wire and then we cut the wire. Go! Yay! Let's see what it was. Let's just log the wire. Oh, it's just like random. Is it random every time? I think it's random every time. Cool! We did it! That was fun. I'm going to save it locally so I don't forget. What is this thing called? Simple time bomb. Cool. Oh, loop through the array and then delete them from the this object, and then you know that it's the only key. That would have worked too. Cool. That was a fun little detour. I'm glad we figured it out on the first try. But basically, they put something on the global that was not meant to be there, and we found it. Get own property names. I guess would that work? Maybe. These answers are from 2015, so it could have been an older version of Node. All right. I don't know if I have the time to solve a 4Q. So let's solve one more 5Q, and then I'm going to go. We'll do games. And hello, Shivam. I'm just solving some katas. Tonight I didn't have any picked out, so I'm just kind of picking them as I go. And the one that I just solved was a very interesting problem where there was some random property that was added to the global object, and you had to find it to defuse a bomb. So, cool. Don't eat the last cake. Oh, that's a good point. So Oliver's saying, I reckon the result of object.keys is ordered by insertion in node. Let's try it. So like, if I say global dot key equals 1, 2, 3, and then I do object.key, yeah, it's the last one in the array. Yeah, because they're the keys. I don't know if that works the same way everywhere, but in this case, the last property that gets added will be the last thing listed in keys. Cool. Okay. Welcome, warrior. Let's play a game. You've gotten challenged by a lot of kata. Now it's time for you to challenge the kata. Oh, man. Inside a room, there's a table with a pile of cakes. These don't really look like cakes. They look like burnt toast or something. I don't know. One of these cakes is filled with poison. Every turn, you will take cakes from this pile and eat them, leaving the last one to be the poisonous cake. Whoever eats the poisonous cake will die. The poisonous cake is clearly marked, so you don't have to guess. Rather, you need to rely on your own logic, to save you. The rules are simple. Do not eat the last cake. It's obvious that poisonous cake will be the last to be eaten, so don't eat the last cake. Try to make your opponent eat it. When it's your turn, you can only take 1 or 2 or 3 cakes. The same. Okay, so it's basically the last one left in the pile. It's like a game where you're taking a certain number out, and then the last one remaining. If your opponent has to take the last one, then they lose. Okay, I've seen games like this. I don't know what it's similar to. You cannot copy your opponent's previous move. Likewise, they cannot copy yours. If your opponent takes 1 cake, next move you can only choose between 2 or 3. If you take 3 cakes, your opponent can only choose 1 or 2. That makes sense. Okay. If one of the players has no valid moves, example, 1 cake left and the previous move was 1 cake, that player will lose his turn and be skipped. Then the other player will be forced to eat the last cake. And this is the only case of turn skipping. Wow. You can choose whether or not to go first. The decision is key to victory. So I'm curious, do we have to solve this, or do we just have to implement the game that allows people to play? Task of this kata. To solve this kata, you should write a class called player as a constructor and 2 other functions. Each test is a different game in different instances of the player class. You should not worry about calling the functions. You should only watch the number of cakes on the table and decide on every move how many to take. Write your player class and beat your opponent. You must figure out a strategy that guarantees you victory. I feel like I just read this whole thing. I feel like I'm committed now, but now I don't know if I want to do it because I'd have to figure out how to actually win this. Okay, so there are 12 cakes on the table. You decide to move first. You ate 1 cake, 11 cakes left. Opponent ate 3, 8 cakes left. You ate 2, 6. Opponent takes 1, 5 left. You ate 3, 2 cakes left. Opponent has no winning choice. If he eats 2 cakes, he will lose. If he eats 1 cake, you'll be left in a stalemate situation. He will gain 1 cake and lose. So, is there some mathematical way of deciding? How does this even work? Let me look at the code. Is it going to be a random game? Or like, here are the games. So do I have to code a player that's going to win no matter what game I play? Okay. I like it. So Phil has a suggestion in the chat. Oh, Josh is saying we would play this in math class for which order we could leave early. It was great. The Coding Cat is asking, how can I be a moderator? Just by hanging out, contributing to the community, answering people's questions, that kind of thing. Both Josh and Oliver and Alka have been hanging out in the YouTube chat for like months now, for a very long time. JT says there's a good YouTube video about this game by Stand Up Maths. And Phil is saying if you win if you manage to always leave a game state where 4 are left. Okay, not sure how that works, but interesting. Oliver's saying for each owned property key of P of O, that is a symbol in ascending chronological order of property creation. Oh, you're talking about the node.js globals thing. I see. All right, I think I'm going to do this. I feel like it's going to take me like an hour to solve because I have no idea how to always end up with 4. Also, oh, we get the number of cakes. So we could keep track of what moves have happened. And also, based on the initial number of cakes, decide if we want to go first. And then decide what our moves should be to always end up with 4 at the end. Yeah, my ear is saying it looks tedious. It does seem tedious. I don't know. It's like the sunk cost fallacy. I've already read this whole thing. Do I just want to save it for next time? Would anyone be mad if I saved it for next time? I'm going to keep looking. Conway's Game of Life. I actually did a live stream a while back where I solved that. Yeah. Bowling score calculator. That seems interesting. I've always been curious, like not curious, but it's always interesting how bowling scores are added up. Your task is to write a function for calculating the score of a 10-pin bowling game. The input for the function is a list of pins knocked down per roll for one player. JT is saying do the bowling one. Save it for next time. I appreciate the encouragement. Because, yeah, like, I could figure it out. And I think Oliver just said, like, ultimately the code is short, but you have to do some maths to figure out the best way to win. So I'll definitely save this one for next time. Let's add a note. Cool. All right. Let's calculate a bowling score. General rules. Rules of bowling in a nutshell. A game consists of 10 frames. In each frame, the player rolls 1 or 2 balls, except for the 10th frame, where the player rolls 2 or 3 balls. The total score is the sum of your scores for the 10 frames. If you knock down fewer than 10 pins with 2 balls, your frame score is the number of pins knocked down. Easy. Then it gets a little bit interesting. If you knock down all 10 pins with 2 balls, that's a spare, you score the amount of pins knocked down plus a bonus, which is the amount of pins knocked down with the next ball. I see. If you knock down all 10 pins with 1 ball, that's a strike, you score the amount of pins knocked down plus a bonus, which is the amount of pins knocked down with the next 2 balls. So if you score a strike, your score is dependent on what you score in the next frame, which makes things interesting. Rules for the 10th frame. As the 10th frame is the last one, in case of spare or strike, there will be no next balls for the bonus. To account for that, if the last frame is a spare, player rolls 1 bonus ball. If the last frame is a strike, player rolls 2 bonus balls. Fun. Let's do it. Okay. I'm excited about this one. I've always wanted to calculate bowling scores because I never knew like the mechanics of it. Like this idea of what you score when you get a spare, or how your score is calculated based on when you get a strike. But this is going to be fun. Okay, there is our function. Here are our tests. Can I do this? Start up Quokka. Yeah, that works. Oh, wow. So it's pairs of 2. This is basically one big array of all the rolls that happen. But wait, how do you determine? Oh, I was gonna say, how do you determine if it was a strike or not? So if it's a 10, you know that there's only 1 ball rolled, at least for the first few frames, except for the last. If it's anything else, you know that 2 balls were rolled, even if it was like 0 and 0. Okay, that makes sense. Yeah, and a perfect score in bowling is a 300. That's when you get a strike for every single ball rolled. Okay, so let's take our rules and figure this out. Okay. So these are the rules. If you knock down fewer than 10 pins with 2 balls, your frame score is the number of pins knocked down. Okay, so I think we're gonna start at the beginning and just look at each value. So we'll iterate over the array, and we're looking at each frame. So Like if the first value in the array is not 10, we know that we need to look at the first two values. Okay. Okay. Oh, and that is a good point. It's only a strike if you score a 10 your first roll in that frame, because if you get a gutter ball, which is a 0, and then you score a 10, it's technically a spare because you had to roll 2 balls to get that. Yeah. Okay, so we start at the beginning, and I kind of want to write like some sort of like smaller function that like scores a frame. So let's say like if rolls at 0 does not equal 10, I'm going to do it for the first frame, and then I think we can wrap this in some sort of like loop. So if rolls at 0 is not a 10, meaning your first ball was not a strike, then we need to score the frame. So let's say like score, we'll write a function called score frame that takes in the frame, which has 2 values. So in this case, we'll say rolls at 0 and rolls at 1. And then there are some cases where it's dependent on the previous frame, so we would need to pass that in. But for now, I'm just going to handle the easiest case. So we have a function. We have, it's called score frame. It takes in roll 1 and roll 2. And in this case, just returns their sum. Roll 1 plus roll 2. We can do the spare logic, though. We'll do this inside of the score frame. So if you knock down all 10 balls with 2 balls, you score the amount of pins you knock down plus a bonus, which is the amount of pins knocked down with the next ball. Oh, that's the next frame. So I think technically you would still need the next frame. It's getting tricky. Because the score for this frame is that I think we'll have our... I was going to say we'll have our logic for looking at the next frame outside of it. Yeah. Okay. But yeah, and this is really the easiest. This essentially is the easiest case where you don't get a spare. If you just got 2 rolls where it doesn't total 10, then you get, that's your score, is all the number of pins. Okay, but let's look what happens with the strike. If you knock down all 10 pins with 1 ball, you score the amount of pins knocked down plus a bonus. So the amount of pins knocked down is 10, so that's your base score, and then you add to that the amount of pins knocked down with the next 2 balls. So you add to that your entire score of the next frame. Yeah. Yeah. And JT is saying you don't need to score the next frame entirely. You can just add the number of pins knocked down. Okay. So let's just call this number of pins. It's super simple. It's basic math, but it'll be good to separate it out. And then we could have our logic like if pins does not equal 10, meaning it's not a strike or it's not a spare, because in this case we're handling where you roll 2 balls. So if the total is not that, then our total score just gets increased. So we'll start our total score at 0. And in this case, we'll add our total score. We'll add pins to our total score. Great. Else, if it was 10, then that means it was a spare, and we need to kind of like carry the 1. So like we could carry the number of pins rolled in the previous frame and add that here. So we'll start our carry off at 0. And if the pins is not 10, great. Is it a carry, though? No, we don't. It's not a carry. Because we don't calculate it until the next time around. Okay. Yeah, we're handling the easiest case. Now let's try to think about how we can handle, and if we were like iterating this. So in this case, we looked at the two balls. Now we're going to move on to the next frame, which is going to be rolls at 1 and rolls at rolls at 2 and 3. I guess let's try to do this in a for loop and like use I here. So yeah, let's just do a for loop. Well, I is less than total number of rolls. And it's not really a for loop. I kind of want to do a while loop, and then we can decide how much we increment I by based on the current frame, because if the current frame was a strike, we're only going to increment I by 1. But if it was a regular roll, we need to increment it by 2. I guess technically we could do that here. Yeah, I think we can handle it in the for loop. Here's what we do. So we'll say rolls at I. So we're starting off at 0. If the first one is not equal to 10, then we're going to score the frame. We have I and we have I plus 1. So these would be like the first two values in the array. Then if our total sum does not equal 10, we're going to add it. Else, let's say we have a variable that's like spare. Because in the next time around, if your previous roll was a spare, you need to add those points again. So in this case, we'll say spare equals true. And then if we came back around and the previous roll was a spare, the amount of pins knocked down with the next ball is just rolls at I. This is getting very brittle. Very, very brittle. Yeah, just the number of pins knocked down. Yeah. Okay. I just thought of another way of doing this. Like, what if we took this array and first broke it down into frames? So each frame would either have 1 or 2 balls. To me, it seems like it would then be a little bit easier to score each frame because we know how many balls were rolled in each frame rather than like trying to keep track of what was rolled. I don't know. I'm going to sort of keep going down this path, but if this gets too hairy, I'm going to go down the other path. So in this case, I really don't need this number of pins function. It's just going to be rolls at I plus rolls at I plus 1. Okay, so we're in a frame. That frame was not a strike. If it was a strike, you score the amount of pins knocked down plus a bonus, the amount of pins knocked down the next 2 balls. Then we'll have another variable. So let's say strike equals false also. So I guess let's work from the outside. Let's handle the strike case. So if the current frame is not a strike, we're going to do some stuff. But if it was, we'll say total score plus equals 10 and strike equals true, because then in the next frame we're going to have to take those pins and add on to the score if the previous one was a strike. Now in the case where it was a strike, we can just increment I by 1 because we need to go on to the next frame. If we're looking at I plus 1 here, we then need to actually increment I by 1 more. So in this case, we actually need to do an I++ so that it skips the second roll of the frame. And then now, when we come back around, we can handle if a spare was true or if a strike was true. So, I guess let's handle the case of a strike. If you knock down all 10 pins with 1 ball, you score the amount of pins knocked down plus a bonus, the amount of pins knocked down in the next 2 balls. Okay, so if the previous roll was a strike, then total score plus equals the total number of pins knocks down, because in the next 2. Else, if it was a spare, then total score gets added on the number of pins in that first roll. So rolls at I. And then here we just want to set spare back to false and strike back to false. So let's take this. Let's try to just think through how this would work here. So we start here. We start at 0. And rolls at I doesn't equal 10, so we're gonna add it up. So this is our score for the frame, which is 10. Strike and spare are currently false because we're in the first frame, and then we reset them anyways in case they were there. And then if actually I'm thinking let's do this just like right out. Let's do this at the start. No. We need it needs to be in here because we need to make sure that they actually scored, or they only rolled 1. Okay. So the number of pins is 10, so it's a spare. What happens in a spare? You score the amount of pins knocked down, so our score actually needs to increase by 10. And then plus the amount of pins knocked down by the next ball. So they scored a spare. We set that to true. And then we increment I once more so that it jumps from here to here, because I was initially 0. Okay, so now we're here, and it's not a strike. The previous one was a spare, so we add 9 more points to the total score, and then reset. And then, in this case, it was a spare, so we set spare to true, increase the score by 10, and go on to the next frame. So I think this is kind of working. Let's imagine the scenario of like all these 10s that were scored, or it could be like a mix of strikes and not strikes. But let's look at the case of all strikes. So we're here. Is it a strike? It is. So we're going to go down here, increase the score by 10, and set strike to 2. To true. I found out we're not handling this stuff in whenever we got a strike. So we definitely need to do that. Because the next roll is a 10, and we're setting strike to true again. So we actually need to handle this. And this is where it gets tricky with the strike, because the strike is the sum of the next 2 balls. So your score in frame 1 would actually be 30, because it becomes 10 plus the number of pins knocked down in the next 2 rolls, which is 20. So your score for frame 1 would be 30. Basically, it's 30 all the way down. Wow, okay. And I'm also not handling the very last frame, but we'll get to that. But I need to handle this here. So if the previous one was a strike, we'll say, this gets tricky. Let me undo that. I'm going to catch up on the chat because I think people were like yelling at me. Yeah, so Josh says, have a strike boolean to make your life easier. I did that. Rogue Soul says, if you get spare, you add the first ball roll points to the total score. If you get a strike, you add 2 ball roll scores to the total score. Yeah. Yeah, and since they're providing, I guess technically, if it was a strike, we can just look forward. We can just look at the next 2 values in the array because we know that the next 2 rolls are what you get. Yeah, totally. Okay, so 10 plus rolls at I plus 1 plus rolls at I plus 2, because it's the next 2 rolls for a strike. The only thing here is we need to make sure that we're not at like the end of the array. And we could do the same thing with a spare. So we just look at rolls of I plus 2, because the current frame we scored a spare, which was these 2, but we want the one after that to be able to add for the spare. Yeah, this is getting us closer. Yeah, and so it's not a live, yeah, and I like what JT's mentioning. It's not a live scoring scenario where you kind of have to wait till the next frame to see what they're going to score. In this case, we already know, so we can just go ahead and add it. I like that. Okay. See you later, Clark. Thanks for tuning in. Yeah, and Oliver's saying the in doesn't work like that, unhelpfully, but we can add a case for that. JT is saying, and then the only additions you need are a counter for the total frames you've counted and a pointer for where the array the current frame starts. And it becomes a whole lot easier if you just use a while loop. I think I'll use a while loop because in this case I'm like making it's kind of wonky. Like if it's a strike, we only know to increment by 1, but if it's anything else, we increment by 2. But if we just use a while loop, we can handle that. I guess also if we use a while loop, we can detect like if we're on the last frame or not. Okay. Okay, but yeah, let's turn this into a while loop. So we'll have current roll equals 0. While current roll is less than rolls.length. Yeah. Then we do all of this. Then instead of I, we use current roll. And then we're not incrementing I anymore. So if they just rolled 2 balls, we'll say current roll needs to increment by 2. And if they got a strike, then we only need to increment this by 1. Go to the next one. Cool. But now we need to handle scoring the very last frame. So, rules for the 10th frame. As the 10th frame is the last one, in case of spare or strike, there will be no next balls for the bonus to account for that. If the last frame is a spare, player rolls 1 bonus ball. If the last frame is a strike, player rolls 2 bonus balls. These bonus balls on the 10th frame are only counted as a bonus to the respective spare or strike. And in the chat, Ed is asking, is the README for the 10K celebration available? I actually did like an Ask Me Anything. It's not, but I should push it up because I have all of the notes in like a README locally. I'll push it up. Okay. So, we need to check and see if the current roll is the 10th frame. And if they get... How's this work? I like it. JT's got all the answers. Do you bowl, JT, by chance? But we can keep track of the number of frames that we've scored, and then every time we increment the total score, we know how many frames that we've scored. I like it. So, total frames scored starts off at 0. And then if we score a strike, we increment it. If we score something that's not a strike, we also increment it. We increment it every time because a frame can either be 2 rolls or 1 roll. So we always increment total frames scored by 1. Cool. And then as the 10th frame is the last one, in case of spare or strike, there will be no next balls for the bonus. To account for that, if the last frame is a spare, player rolls 1 bonus ball. So then, technically, you would have 1 more ball that's rolled. Okay. I'm seeing it. JT is saying, I haven't bowled in more than a decade. It's probably been a couple of years for me, and I'm not good at all. I'm not a good bowler. Okay. I think we're getting there, though. In the case where the very last frame is not a spare or a strike, our code works. But when the 10th frame is a spare or a strike, we have to account for that. Okay. If the last frame is a spare, player rolls 1 bonus ball. So if the last frame is a spare, so this is a spare right here. JT's saying the only thing broken is my while loop condition? Do I really just look if total frames scored is less than 10? Yeah, I want to see what's the value that I'm getting versus what it is. Do I really just need to check that? Total frame scored is less than or equal to 10? No. Frame 11 is not a real thing? Well, total frame scored... Oh, because it starts off? That does it! That's too easy. I spent way too much time on this one. And JT basically wrote the whole thing. Oliver's saying, if your strike frame is 9 and then strike frame 10, the first bonus for frame 11 doesn't count for the frame 9, which will cause you some problems with your strike look ahead. Yeah, because frame 11 is not a thing. But it works. Why does it work? I don't know, but I am kind of tired. That was fun though. Okay, why does that work? Because if we're looking, let's take the case where here there are 12 total rolls because you got to strike every time. So yeah, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 plus the 2 bonus rolls. So if we're at total frames scored, when that gets set to 10 right here, it stops counting, but we're adding the next 2 strikes. So that works. And then in the case where the last frame is a spare, you only get 1 extra ball. So the last frame gives you a 10 plus 1 more, and then total frames is maxed out. So this works. Yeah, we're not going over. Okay, makes sense. JT says I barely touch the keyboard, but you I don't know. Thank you for your help. Okay, I think I'm done. I'm gonna submit this. Hopefully it works, and then I can go to bed. Cool. Final. I know. I do think the scenario where you're scoring things live is a little more interesting because you don't know what the next frames are going to be, so you do have to hold on to, like, was the previous frame a spare or a strike, so that you know to add in the next one. But in this case, they gave us the entire thing. Cool. All right. This person used a reduce. Interesting. So if the number of frames is 10, then it's just the total sum. Easy. Is a strike. If the first roll is a strike, this is a recursive solution. Basically, they're like taking off the first the frame and then scoring each additional frame and summing it all together. Wow, that's pretty nifty. Okay, so we're keeping track of number of frames, which roll we're on. Cool. I like my solution. I think it looks pretty readable. Cool. All right, that's it. I'm gonna push my code up. I'm also going to push up my answers to the Q&A, Ask Me Anything for my 10,000 subscriber stream. So I'll do that. I'll post the link in Discord for that if you're on the Discord. And I'm going to go now. Thanks, everyone, for tuning in. Thanks for all the help in the chat from JT and Oliver and Alka and anyone else that provided suggestions that helped me out. In terms of the next stream, I don't know, but I think you can look forward to a stream this weekend. May or may not be T. I have an idea for an app that I want to build, so maybe I'll do that this weekend. But just watch the channel. Something will happen. All right. Yeah, I think that's it. I'm tired. Wherever you are in the world, have a wonderful morning, afternoon, evening, or night. We'll see you next time. Here's this.